Okay, fams, this is the second question we're given as a take home on projectile. A hose lying on the ground shoots a stream of water upward at an angle of 40 degrees to the horizontal. The speed of water is 20 meters per second as it leaves the hose. How high up will it strike a wall 8 meter away, and with what speed will it strike? Now, this question is very simple and direct. Well, first of all, let's try to see if you can get a pictorial interpretation of this very question. Now, her hose, there's a wall like this. You have a wall this way, standing like this, you have a wall. So, while on the ground, we have a hose, probably shooting out water. You have a hose. So, this hose shoots water out outward. Look at, let's say a hose shoots a stream of water upward at an angle of 40 degrees to the horizontal. The speed of the water is 20 meters per second. So this what happens. The water leaves with this speed, 20 meters per second. Now at an angle of what? 40 degrees to the horizontal. 40 degrees to the horizontal. So it's very direct. Now, don't forget that this everything happening from this place, from this hole, as a host shoots out water. Now it's shooting it onto a wall that is how many meters away? The wall, according to the question, the wall is 8 meters away. There's a wall here. A wall just happens. There's a wall here. While a hose shooting out some water from this angle of 40 degrees to the horizontal, the water keeps pumping out. So the question is, how high up this wall will the water hit? According to the question, look at it. How high up will it strike a wall 8 meters away? So it's very simple. So the best thing we're going to use, we're going to be using the trajectory formula. Don't forget that we have to distances simultaneously. We have distance along the x-axis and also the distance they want us to look for, the distance along the y-axis. How high up the wall? So don't forget a very popular formula. So distance along the y-axis is distance along the x-axis tan theta, then plus 1 over 2 gravity, then distance along the x-axis squared over initial speed squared cos squared theta. That's what we have. That's what we're using again. We're going to be using this trajectory formula. Don't forget that this formula is mainly applicable when we talk about distance both along the x-axis and y-axis simultaneously. We're not talking about range. There's not really range. We're not talking about mass height. We're talking about two distances at the same time. So now don't forget. First of all, we have distance along the y-axis, along the x-axis. I beg your pardon. It's already given. It's 8 meters. So we have the angle theta 40 word, 40 degrees. So we're asked to get how high up the distance along the y-axis. That's what we're asked to get. So the initial speed of the water is given